up, guys? It's Mr. Hansen at Mr. Hansen 44. Here's Kay. She came down here because this kid likes to come downstairs. So again, this is part of my remake videos because my mic wasn't working, and I need to get these videos to you guys. So we're gonna get started right away. 5.2 ASA Triangle Congruence, and the whole deal here is to try to prove that triangles are congruent when you're given an angle and a side and an angle. So not just any angles and not just any sides though. So the ASA Triangle Congruence Theorem, the essential question, tells you that if you have two angles and the included side of one triangle and they're congruent to two angles in the included side of another triangle, the triangles are going to be congruent. So that is what it is, because sometimes you can't check all three pairs of corresponding sides and all three pairs of corresponding angles. The 6 pairs what we did for CPCTC, you can't always do that, and we have these shortcuts, and one of them is ASA. Again, good notes are going to help you quite a bit here. In a polygon, the side that connects two consecutive angles is the included side. So if we were looking at this angle here and this angle here, the included side would be this line segment AB. So let's just get right to the money. So in looking at these, again, you guys know I don't mess with the traits there. See ya. Say bye-bye. Bye. Angle measure A is congruent to angle measure D. Angle measure B is congruent to angle measure E, and line segment AB is congruent to line segment DE. Something like that. You can clearly see that you have two angles and the side in between. Think of like a finger trap. So what can you do to show that these triangles are congruent? Well, you could find a sequence of rigid motions that maps one triangle to the other. That always works, right? You can translate one, you can rotate one. How do you know the image of point B is point E? Well, you know, it's given that AB is congruent to DE, so the point of B must be point E. Clearly F is a reflection across DE. Again, I don't know what that is. Going a little quick because it's almost time for y'all to start class and I gotta get these videos uploaded. Here we go. Just go right here. Explain 1. Deciding whether triangles are congruent using ASA Triangle Congruence. Well, if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangle is congruent. Get these notes in. It's confusing. There's a lot of abbreviations, acronyms with these ones, so please take good notes. So example 1, let's take a look and make sure that this makes sense to you. So triangle sum theorem, we're seeing that the three angles must add up to 180. We have a missing angle, therefore we can find out that that is 45 degrees. Now, what can we compare? Well, you can compare angle measure A and D. A and D. You can compare side length AC and side length DF. And you can also compare angle measure C and angle measure F. So, two angles, the included side, ASA. They're all congruent. Each pair of corresponding parts is congruent. So here's one, a little guided practice. If you want to pause and try it yourself real quick, go for it. So we're going to hop right in. So we got 31 degrees here for a measure of M and 38 degrees here for a measure of N. M and N. So look where that's going to go. Well, M is clearly going to be up here with J, right? So we add that up, we solve, and we get the angle measure of P is 111 degrees. So that 111, that means K is 111, right? Yes. No. Yes. Yes. I was tripping. So you should see right away, guys, this is not going to be congruent because the angle measure pairs are not the same. If any part is not congruent, it's not. This triangle is not congruent. Do you have to know angle measure K? No. You only got to know the parts that you have. All right. Your turn. You might want to pause here. Taking a look. Because right angle ones are kind of a cheat code, and these are clearly congruent. These are marked as congruent, so this is going to be congruent. Letter 6, though, is not going to be congruent. You can clearly see that right here. because if you were to find the missing angle, it's not going to be equivalent. If any part is not congruent, if any pair of corresponding parts is not congruent, the triangle is not congruent. Write each proof. I know. So do your best here. So you're given, always write down what you're given, figure out where it is on the diagram, figure out what it means. So the angle measure of MQP is congruent to NPQ. And the measure of MPQ is congruent to NQP. Prove the triangle is congruent. So we already have two sets of corresponding angles that are congruent. For using ASA, you look for a side. Well, looking here, this is, like a very simple case, right? Because if they share a side length, they're obviously the same side. That means they're obviously equal. They're obviously congruent. So because of the reflexive property of congruence, and again, if your verbiage isn't super mathy, but you can still prove your argument, math practice 3 is super important. That's all that really matters to me. So therefore, you can state that via the ASA Triangle Congruence Theorem, these triangles are congruent. So here's another one, a little hourglass-looking bow tie thing, looking like the Larry, was it Larry? Terry from Soul? That was a good movie. So you're given angle measure A is congruent to angle measure C. You're given that E is the midpoint of AC. So midpoint, and these two are congruent. So that's a given. That's a given. So what do we got to prove? Well, if we're dealing with that angle, we got to deal with what's in between. So we're trying to prove that these two line segments are equivalent, are congruent, and that's via the definition of the midpoint, def of midpoint definition, because E is the midpoint, so therefore the side lengths on each side are equal. So we have to prove that angle AEB is equivalent to angle DEC. Well, or CED, same thing, but you should remember this. Vertical angles definition, vertical angles are congruent, and therefore it's an ASA Triangle Congruence Theorem proof. So you got two pairs of angles, the included side, done. That is what this looks like. If it was me, I'd go back and get these examples into my notebook or onto my Jamboard, and then get it in my notebook so you know what's up. So I would pause here, give it a shot, and I'll go through real quick. So here's what we're given. JLM. So JLM is equivalent to KML, and JML is equivalent to KLM. Two angles. So I'm going to write these out. So JLM equivalent to angle KML. That's a given. Angle JML KLM. That's a given. Okay, so what do we got to prove? Well, if you see these angles, what's the included side? It's line segment LM, and it's shared. So you want to prove that they're the same. And this is just like last time, and it's the reflexive property of congruence. Reflexive property of congruence, just like the example from above. And then you can go ahead and write this here and say that via the ASA Triangle Congruence Theorem, your triangles are congruent because the two angles in the included side are congruent. Corresponding parts helps you figure that out. Another one. I'm going to pause. So here's what we're given. So you're given that SU, angle S and angle U are 90 degrees, right? That's given. You know that those two angles then have to be equivalent Y, or congruent I should say, because all right angles are congruent, right? Yes. RV bisects SU. So let's start getting some stuff on the diagram now, right? So S and U are congruent. I should have marked that like a right angle, but whatever. Congruent. RV bisects SU. We can visibly see that, right? So given. ST is equivalent here. ST is equivalent to TU. Do you remember what that one is? Bisector. So that's via the definition of a bisector. Bisector definition. Cuts it. Def. And then we have angle RTS and angle VTU. And you should know that these are congruent because I'm hoping that your brain's tinging, bling blinging. Vertical angles. Vertical angles. And now you have proved that these two angles and the included side are all congruent. Therefore, via ASA, your triangles are congruent. So you see, it kind of gets repetitive, but you know, it's like a puzzle. Figure out what you have, figure out what you don't have, and try to find the congruence theorem part. So for this one, this is our first one, right? It's ASA. We also have CPCTC. So you figure out the situation, what you have, and which one you can use. For for number 10, it's important to remember that it matters on corresponding. The corresponding parts have to be the same. They have to be congruent. So the shape could be the same, but they may not be the same size because that other side could be longer. So you have to make sure that they match up. And if they don't match up, they're not necessarily congruent via this theorem or at all. Yeah, and that's about it. You know, you want to make sure for ASA congruence theorem you can prove that two triangles are congruent by using just three pairs of congruent parts. So you have the two angles and the included side, and it has to be the included side. It can't be a different side. So two angles, included side. I think of a finger trap. I also think of like compound inequalities, if that rings a bell. Homework, you know, again, do what you need to do. I would do a couple of each. Really get used to writing the proofs, finding the givens, drawing up the diagrams, and just getting used to the ASA examples. I would make sure I take really good notes on this as well. And you get, you know, a little more challenging stuff, I would take a look and give yourself a shot if you want to push yourself, especially to be advanced. So yeah, that's all I got for this one, guys. ASA, Triangle Congruence Theorem. Hopefully the video helped, made sense. If not, hit me up, and I'll be back soon.